on AFCAT Engineering Knowledge Test Preparation for Electronics branch. So the examination is going to happen on February, and this is a part 2 of previous year questions from the Engineering Knowledge Test or EKT. Okay, so we'll be doing more questions in this video. Let us see what is the first question. An FET is a dash. Option A, bipolar semiconductor device. B, unipolar semiconductor device. C, non-semiconductor device. D, both A and C. So, if you look at the transistor classifications, basically there are two types of transistors, bipolar junction transistors and field effect transistors. So, BJT and FET is a classification, right? We'll be seeing the basic difference between these two transistors, BJTs and FETs. BJT means BJTs are bipolar junction transistors. So if BJT is bipolar junction transistor, then FET is unipolar junction transistors. You have been hearing this term unipolar, bipolar. Now, what is actually this unipolar, bipolar? If you see the BJT, in BJTs, the current is contributed from electrons and holes. Holes are actually some vacancies which have been created by the absence of an electron, right? So holes, we can say it only as theoretically. We cannot say that such a thing exists because holes are actually a vacancy which is having a positive charge, and this vacancy is created by the absence of an electron. Anyway, we consider of the holes while considering the current production or current conduction. In BJTs, we say that electrons and holes contribute to current. Okay, so that is why they are being called as bipolar. Whereas in FETs, if you see, there are only one type of current carrier contributing the current, mainly electrons. So that is why they are called unipolar. Now from today onwards, if somebody is asking you what is the difference between BJT and FET, don't just say that one is unipolar and one is bipolar. You should be able to correctly say this, that one is having current contributed by both electrons and holes, whereas the other one is having current due to the presence of electrons only. Okay, so that is why they are called, this one is bipolar and this one is unipolar. That is a main difference. Next one, another major difference is that BJTs are current control devices. Current controlled. Whereas FETs are, the name itself is field effect transistor. Field means voltage or potential difference. Field effect transistor means due to the effect of this field or this voltage, the transistor is being affected. So it is voltage control device. Okay. These are the major difference. Other differences are there, but if you know this difference, then you understood actually some concepts about BJTs and FETs. Okay, so this is voltage control and the BJTs are current control. Now from this explanation, you can answer this question. So FET is a dash type of device. FET is a unipolar semiconductor device. Here the current conduction or the current is contributed by only single carrier, type of carrier, that is the electrons. So they are unipolar devices. Correct answer is option B is your correct answer. Next, ideally voltage standing wave ratio, that is VSWR, should be dash. So VSWR is some term related we'll be discussing in electromagnetic theory and also in microwave engineering. Okay, we have explained a lot about VSWR, especially I've done a spread video on this VSWR, and also while explaining many questions in ISRO technical assistant videos and scientist videos, I've talked about VSWR. So if you are not familiar with this, please do watch the video on VSWR. Okay, anyway, voltage standing wave ratio should be, ideally, what should be the value? Option A, as large as possible. Option B, as small as possible. Option C, as close to unity, that is as close to 1. And D, infinity. What should be the value of VSWR ideally? Okay, so this VSWR should be equal to 1 ideally. Anyway, one thing is clear, that voltage standing wave ratio is actually, if you know about VSWR, it has been created due to the reflection of the wave back to the transmitter. So you should know the basics of VSWR to answer this question. So VSWR is actually, see, in transmission lines also, we are sending some waves, right? We are sending some waves. There is a source, there is a receiver here. So we are sending some waves to the receiver side from the source side. What will happen due to some mismatch of impedance or any other factor at the receiver side from the source side, the wave will reflect back towards the source. Okay, so this reflection will create some standing waves. That is, waves have been traveling in this direction also, in the reverse direction. That is, the waves are getting reflected also. So due to this movement, that is forward and backward movement, we say that some standing wave is created, and due to this the VSWR is occurring. Okay, and the value of VSWR is calculated from the equation VSWR is equal to 1 plus rho by 1 minus rho. Okay, where rho is called reflection coefficient. As I said earlier, this VSWR is created due to what? Due to the reflection of waves back to the source side. Okay, so the value of VSWR, if it is equal to 1, what will happen? If VSWR is equal to 1, 1 minus rho is equal to 1 plus rho, right? So for that case, we'll get 2 rho is equal to 0, or we'll get rho is equal to 0. So if VSWR is equal to 1, the value of reflection coefficient will be equal to 0. So that is our desired case, right? We don't want any reflections back to the source side. We are actually sending some wave to the receiver side. We don't want it back. We don't want any reflections back, right? So that is our desired case. So in order to have no reflections, or in order to have no reflection coefficient, or the value of reflection coefficient equal to 0, we need VSWR ideally equal to unity or equal to 1. So if you go on talking a lot of theory things about this question, there is a lot to talk, but I am briefing it. Okay, so the value of VSWR should be ideally equal to 1 in order to have no reflections back to the source side. So from the source side, we are sending some wave to the receiver, and that path only is required. The reflections is not required. So the reflection, we don't want it. So we make, or ideally VSWR should be equal to 1 in order to have no reflections. That is the concept you should know to answer this question. Okay, so what will the answer for this question? It is C, as close to unity. Okay, so the ideal value of VSWR is equal to as close to unity, or is equal to as close to 1. That is the answer for this question. Next question is this: inverse Laplace transform of 2 by s plus 1 is dash. Very simple question. You only need to know about Laplace transform, and that too very basic thing is been asked here. What is the Laplace transform of L of e raised to minus t? It is 1 by s plus 1. So that is only the thing you should know to answer this question. So if Laplace transform of e raised to minus t is 1 by s plus 1, then what is the L inverse of 1 by s plus 1? It is e raised to minus t, right? So e raised to minus t. Another term is there, that is 2 by this term. So here it is 2 into. Simple, right? So the correct answer is option B is your correct answer, which is 2 into e raised to minus t is your answer for this question. Next question. The transfer function of a system is used to calculate dash. A, steady state gain. B, the time constant. C, the order of a system. D, the output for given input. Now, if you go on talking about the transfer function, it can be used for finding many things. But primarily, what is the function of a transfer function? You can express a transfer function either in Z transform, that is h of Z, or you can write it in the analog domain as h of S. Okay, so this is for discrete time signal, this is for continuous time signal. H of s is for continuous time, H of z is for discrete time. If you write the expression for H of z, it is y of z by x of z. That is a standard format. And also for H of s, it is y of s by x of s, right? So this is the expression for a transfer function. Transfer function is a function of a system which represents how the system is going to behave if you give some input. That term or that function is called transfer function. That is the definition of a transfer function. Now from this term, it is output by input, right? Transfer function is simply output by input. That is, transfer function is the ratio of output for given input. That is the correct answer for this question. Again, if you go on using this transfer function for finding many things, it can be possible. But primary function of the transfer, that is primary definition of the transfer function is this. It is the output of a system for a given input. Okay, so transfer function is y of z by x of z or y of s by x of s is your answer. Correct answer is option D is your correct answer. That is, it is an output for a given input. In a JFET, drain current is maximum when VGS is dash. A 0, B negative, C positive, D equal to VP. So JFETs are basically two types, N channel JFET and P channel JFET, right? So JFET is two types, N channel and P channel. So for both these cases, the value of drain current is equal to maximum, or it is called IDSS. Maximum drain saturation current is occurring when VGS, that is gate to source voltage, is equal to 0. For both the N channel and P channel JFETs, the value of drain current is maximum when the gate to source voltage is equal to 0, and applying a value of drain to source voltage, particularly for N channel and P channel according to their configuration. So for either this case, VGS should be equal to 0 to get the maximum of drain current. So the correct answer is option A, 0 is your correct answer. Next question. The signal is extended from 96 kilohertz to 100 kilohertz. So the maximum sampling frequency required is dash. So here we are talking about sampling. So whenever we are talking about sampling, one formula or one equation should come into your mind, that is called the Nyquist sampling equation or the Nyquist sampling theorem. This should be very much familiar. Nyquist sampling theorem. So this is the condition in order to have an ideal reconstruction of your signal which is sampled. So whenever you are sampling a signal, you should follow this rule to reconstruct the signal back to the continuous form. So here the signal is extended from 96 kilohertz to 100 kilohertz. So now what is the maximum frequency of the signal? It is 100 kilohertz, right? So the maximum frequency is 100 kilohertz. Since it is extended from 96 to 100, the maximum is 100 kilohertz. Now if you are going for sampling this 100 kilohertz signal, then Fs or the sampling frequency should be greater than or equal to 2 Fm, where Fm is 100. Equal to 2 Fm is a minimum frequency required. It should be greater than or equal to. Okay, here it is. Fm is 100 kilohertz, so into 100k, that is Fs should be greater than or equal to 200 kilohertz. Minimum how much is required? Minimum you require 200 kilohertz to sample the signal following the Nyquist or Nyquist sampling theorem. So what is the correct answer here? It is B, which is 200 kilohertz is required. Okay, also if you see the other options, one is 8 kilohertz which is very less, C 4 kilohertz and D 100 kilohertz. So you should know this equation. Fs should be greater than or equal to 2 Fm to sample a signal according to the Nyquist sampling theorem. When a conductor cuts magnetic flux, an EMF is induced in the conductor. This is called Faraday's law of induction. This is a basic principle of working of either the transformers, that is in the primary coil, the secondary coil, that is basically the working of inductors. This is the primary law, and it is called Faraday's law of induction. That is, whenever a conductor is cutting magnetic flux, an EMF is induced. It is called Faraday's law of induction, and the correct answer is option B. Next question. If the antenna diameter of radar is increased by 4, the maximum range is increased by dash. So in order to answer this question, you should write the equation for the maximum range. That is, R max is equal to PT, transmitted power, into G, gain, into sigma, into AE by 4 pi square into S minimum. Okay, all these terms I have explained in my earlier video, that is the video on a radar. If you want to know what is this equation, what are the terms, please do watch that video. So, into, another term is there, into the whole raised to 1 by 4. So, this is the equation. Now, where comes the antenna diameter? The antenna diameter is coming in the AE, effective antenna aperture. What is the effective antenna aperture? It is pi r square. Okay, so in terms of diameter, you can write it as pi into d by 2 the whole square. Okay, now here this is equation. In this, they have been increased the diameter by 4. So along with this diameter, there comes a 4. That is 4d by 2 the whole square. So d by 2 whole square is present there. We'll take the 4 square outside. So 4 square, or you can write it as 16. Okay, so this is the new antenna effective aperture. In the equation, we can write this is what? This is A itself. So AE into 16. This will be your change. So all the terms are same as the previous case. Only difference is there is a 16 in the numerator, right? So we'll take that 16. This R dash max, that is new range, is equal to 16 raised to 1 by 4 into R max, which is a previous range. So 16 raised to 1 by 4 is the additional term. What is 16 raised to 1 by 4? You can write 16 as 2 raised to 4, right? So 2 raised to 4 by 4. So this get cancelled. So 2 times R max. So your range will be 2 times if you increase the antenna diameter by 4. So the correct answer is option A is your correct answer. That is, if you increase the antenna diameter by 4 times, the range is increased by 2 times. Correct answer is option A is your correct answer, which is 2. So these are the questions which I have included in this video. I'll be doing more videos on the AFCAT preparation. I've been receiving a request to do the videos on AFCAT preparation, which is going to happen on February. So if you are from electrical branch or electronics branch or electronics and instrumentation branch, and if you are applied for this examination, you can watch this video. Any person related to the electronics brand, that is electrical and electronics also, and electronics and communication also. For all of them, electronics is common, right? So these are the preparation videos for your engineering knowledge test. I hope this video was useful for your preparation. If yes, please do give it a thumbs up, and also share this video with maximum of friends who is preparing for AFCAT examination. And if you want more videos, please do subscribe to the channel. Thank you.